In this video, I will demonstrate the working of a model of a DC motor that I made using some discarded material, a set of magnets, and a cell, electric cell or a battery. Any DC motor basically consists of a coil or a set of coils mounted between the magnetic poles. The magnetic poles can be either permanent or electromagnet. The coil is mounted such that it's free to rotate on its axis between the magnetic poles. The DC motor, or any motor for that matter, works on the fact that the current carrying conductor in external magnetic field experiences a force. A current carrying coil placed in external magnetic field will experience a torque, and this torque makes the coil rotate. The torque is directly proportional to the current in the coil and the strength of the magnetic pole. Here are the parts of the model of a DC motor. Here is the coil that I made of copper wire wound on a cutout from a plastic container. The two ends of the coil are attached to two metal plates that I have attached to the two opposite sides of the axle. The blue colored axle, is a discarded ballpoint pen refill. So two ends of the coils are here attached. There is a gap in between. They are not touching each other. In actual DC motor, these two parts, which are the ends of the coil, are called commutator. They convey the current to the coil when they are connected to a set of brushes. Once you'll understand what these brushes are, they brush against the commutator plates when mounted. So I've made my brushes here for my motor from a discarded cartridge of a shaving blade. These two are actually shaving blade, need to be handled carefully. They're sharp, so needs to be handled carefully. So here is the coil, the brushes, set of magnets here, and a power source, DC power source, which is a 9-volt battery. You can use 3-volt battery or 6-volt battery. And here is the base on which I'll be doing the assembly. These are the two small pieces on which the coil will be mounted. And this small plastic piece, again a cutout from some plastic container on which the brushes will be mounted. So I'll assemble this motor and I'll show you how it works. So here is the assembled motor. The coil is mounted on its mounts here, two sides. You can see that. How's the coil? It's mounted. And as I'd said, these two blades that I've used from a shaving blade cartridge are brushing against those two metal plates, and that's why they're called brushes. In actual DC motor, small DC motor also, there are metal plates, but on a big DC motor, the brushes will be usually made up of carbon. They're called carbon brushes. So two ends I have attached to the wire to which the power supply will be given, DC power source, and these are the two magnets. Let me connect this and see how it works. Connecting one end to the positive, the other end to the negative of this. Okay, and I'm going to keep one magnet here. This is not a self-starting motor. Self-starting motor needs more the more number of plates, that is the commutator, and more number of sets of coils. So here, this is a push start motor. This magnet is making it move. Okay, I bring in another magnet and see what happens to the speed or the RPM. It's definitely increased. This is how the DC motor works. You need a set of magnets. I take away the magnet. One magnet I've taken away. Speed has reduced. I take away another magnet. Stops working. Though there is a current still. So here, this is a push start motor. This magnet is making it move. Okay, I bring in another magnet and see what happens to the speed or the RPM. It's definitely increased. This is how the DC motor works. You need a set of magnets. I take away the magnet. One magnet I've taken away. Speed has reduced. I take away another magnet. Stops working.